Olefin fiber is a synthetic fiber made from a polyolefin, such as polypropylene or polyethylene. It is used in wallpaper, carpeting, ropes, and vehicle interiors. Olefin's advantages are its strength, colourfastness and comfort, its resistance to staining, mildew, abrasion, sunlight, and its good bulk and cover. History: Italy began production of olefin fibers in 1957. The chemist Giulio Natta successfully formulated olefin suitable for more textile applications. Both Natta and Carl Ziegler were later awarded the Nobel Prize for the work on transition metal catalysis of olefins to fiber, also known as Ziegler-Natta catalysis. U.S. production of olefin fibers began in 1960. Olefin fibers account for 16% of all manufactured fibers. Major fiber properties: olefin fibers have great bulk and cover while having low specific gravity. This means warmth without the weight. Quote, "The fibers have low moisture absorption, but they can wick moisture and dry quickly. Olefin is abrasion, stain, sunlight, fire, and chemical resistant. It does not dye well, but has the advantage of being colorfast. Since olefin has a low melting point, textiles can be thermally bonded. The fibers have the lowest static of all manufactured fibers and a medium luster. One of the most important properties of olefin is its strength. It keeps its strength in wet dry conditions and is very resilient. The fiber can be produced for strength of different properties. Production method: the Federal Trade Commission's official definition of olefin fiber is a manufactured fiber in which the fiber-forming substance is any long-chain, synthetic polymer composed of at least 85% by weight of ethylene, propylene, or other olefin units. Polymerization of propylene and ethylene gases, controlled with special catalysts, creates olefin fibers. Dye is added directly to the polymer before melt spinning is applied. Additives, polymer variations, and different process conditions can create a range of characteristics. High-pressure production, which uses 10 tons per square inch, creates a film for molded materials. Low-pressure production uses a low temperature with a catalyst and hydrocarbon solvent. This process is less expensive and produces a polyethylene polymer more for textile use. The polymer is then melted, spun by a spinneret into water, or air-cooled. The fiber is drawn out to 6 times the spun length. Gel spinning is a new method in which a gel form of polyethylene polymers is used. Physical and chemical structure: physical olefin fibers can be multi- monofilament and staple, tow, or film yarns. The fibers are colorless and round in cross-section. This cross-section can be modified for different end uses. The physical characteristics are a waxy feel and colorless. Chemical: there are 2 types of polymers that can be used in olefin fibers. The first, polyethylene, is a simple linear structure with repeating units. These fibers are used mainly for ropes, twines, and utility fabrics. The second type, polypropylene, is a 3-dimensional structure with a backbone of carbon atoms. Methyl groups protrude from this backbone. Stereoselective polymerization orders these methyl groups to the same spatial placement. This creates a crystalline polypropylene polymer. The fibers made with these polymers can be used in apparel, furnishing, and industrial products. Manufacturers: the first commercial producer of an olefin fiber in the United States was Hercules, Inc. Other U.S. olefin fiber producers include Asota, American Fibers, and Yarns Co., American Synthetic Fiber, LLC, Colorfi, Fiber Visions, Foss Manufacturing Co., LLC, Drake Extrusion, Filament Fiber Technology, Inc., 10K Geosynthetics, Universal Fiber Systems, LLC. Trademarks according to fabric use. Producer: Allied Signal A. CE Tire Cord, Furniture Webbing. Producer DuPont Coolmax, warm weather and action wear. Holofil, Quilofil, fiberfill and insulating fibers. Sontara, spunlace non-woven fabrics. Thermostat, cold weather wear. Thermaloft, fiberfill and insulating fibers. Tyvek, used for house wraps to postal envelopes to clothing. Producer Travera ESP, apparel and furnishings. Cell wet non-wovens. Comfort fiber, staple fiber for apparel uses. Floor Guardian, gym floor carpet protection system. Loft Guard, staple fiber for industrial uses. Polar Guard, Lambda, filament yarns with spun yarn characteristics. Serene, Superba, Travera HT, marine and military uses. Ropes, cordages. Travera Pro Oth, recycled content geotextiles. Travera XPS, carpeting. BTU, cold weather apparel. Producer 3M Thinsulate, cold weather action wear. Uses apparel, sports and amp, active wear, socks, thermal underwear, lining fabrics. Home furnishing. Olefin can be used by itself or in blends for indoor and outdoor carpets, carpet tiles, and carpet backing. The fiber can also be used in upholstery, draperies, wall coverings, slip covers, and floor coverings. Automotive. Olefin can be used for interior fabrics, sun visors, armrests, door inside panels, trunks, parcel shelves, and resin replacement as binder fibers. Industrial. In an industrial setting, olefin creates carpets, ropes, geotextiles that are in contact with the soil, filter fabrics, bagging, concrete reinforcement, and heat-sealable paper. Care procedures. Dry cleaning. Olefin is not recommended, because many dry cleaning solvents can swell the fibers. As olefin dries quickly, line drying and low tumble drying with little or no heat is the recommended method of drying. Since olefin is not absorbent, waterborne stains do not present a problem. However, oily stains are difficult to remove. Most such stains can be removed with lukewarm water and detergent, but bleach can also be used. Olefin fiber has a low melting point, so items should be ironed at a very low temperature, if at all. Items such as outdoor carpets and other fabrics can be hosed off. Olefin is easy to recycle.